Congratulations! If you made it this far, you've made it to the end of college algebra. For this lesson, we're talking about systems of inequalities. Last lesson, we talked about systems of equations and how to solve those by substitution, elimination, graphing. Today, we're talking about systems of inequalities and how to solve those specifically by graphing. So with an inequality, we've talked about before, they have, instead of having an equal sign, they have a less than or equal sign. They may have a less than sign. They may have a greater sign. They may have a less than or equal to, a greater than or equal to. They could have any of those signs. And just like when we talked about inequalities when we're just solving a linear equation, instead of having, these match with open circles, right? They also match with parentheses. This matches with a closed circle and with a bracket when we were talking about solving just a linear equation. This time when we go to graph these lines, a less than or greater than is going to match with a dashed line. Less than or equal to, greater than or equal to is going to match with a solid line, okay? So when we graph, we're going to graph with dashed or solid lines based on if we have that equals property or not. So what we're going to do, the steps are, we're going to graph the equation as if it was an equation, right? We're going to think about it as if it was an equation. The only difference is if it's less than or greater than, we're going to draw a dashed line. If it's greater than or equal to or less than or equal to, we're just going to treat it like normal and draw a solid line. Then once we have it graphed, we're going to choose a point to test anywhere on the graph that is not on that line, that's not a part of the equation, right? We want something that's not a solution of the equation. Anywhere else, if we can pick, we want to pick the easiest points we can, right? So if 0, 0 is not a point on that equation, then we're going to test it. And then if that point makes a true statement, then we're going to shade that region. And if it does not make a true statement, we're going to shade the opposite region. Here's an example, 3x minus 2y equals 6. Hopefully you're getting good at graphing lines. So what I would be looking for here, if I wanted to graph this, we could either get the x-intercepts and the y-intercepts, or we could get it to be y equals mx plus b. I think most people are used to looking at the y equals mx plus b form. And so that's what we'll do, y equals mx plus b. We want to get y by itself, so we can subtract 3x. Negative 2y equals negative 3x plus 6. We can divide by, that's not an equals. This is something you really have to pay attention to here. You get so used to writing an equal sign. Divide by the negative 2. And what's going to happen, remember with inequalities, anytime you multiply or divide by a negative, you have to flip that inequality sign. The same thing happens here. So y is greater than. See the inequality sign flip because we divided by a negative. Divided by a negative number. Then we have to flip the sign. All right, that makes positive 3 over 2x minus 3. Let's see what happens if we graph this. Y is greater than positive 3 over 2x minus 3. So this is your m, that's your b. We're going to start at the b, negative 3. Then from there, we're going to go up 3 over 2. That's our slope. If you need help graphing lines, you can go back and look at, there's a section in Unit 2, I believe. I'll have to go back and find exactly what section that is, and I'll put it in the notes on Canvas. But there is a section where we were just graphing lines. All right, this, now, are we going to have a solid line or a dashed line? Notice here we have a just strictly less than. That means we're going to have a dashed line. A dashed line through those 2 points. And now, anytime we can check the point 0, 0, we should, because it's going to be a really easy point to check. It's going to make things go away. It's going to make things cancel out. So what we need to do is we need to know, can we shade this way or can we shade this way? We're going to have to shade half of this graph. What I'm going to do is I'm going to pick a point, again, that's not on the line. So notice here, 0, 0 is not on the line. So if I said 0, 0, I'm going to test it. I'm going to test 0, 0 to see if it works. So that'd be 3 times 0 minus 2 times 0 is less than 6. Is that true? I'm taking my original equation, okay, and I'm subbing in 0, 0. Is that true? That'd be 0 is less than 6. Yes, that is true. That means I can shade towards the point 0, 0. 0, 0 is a solution of this inequality. So I can shade everything in this side of the graph. If I'd got something that was false, if 0, 0 was not true, then I could either pick another point, right? on the other side of the graph and test it, or I can just realize it's going to be shaded the opposite way. Here, since 0, 0 works, we'll shade towards 0, 0. All right, again, if we can get it to be y equals mx plus b, then we can graph it a little bit easier. If I divide both sides by 4, I get y is less than 3 over 4x. That's the same thing as 3/4 x plus 0, right? And so when we graph it, start at 0, then go up 1, 2, 3 over 1, 2, 3, 4, put our next point. Here, since we did start with a less than or equal to, we're going to have a solid line, not a dashed line. Solid line through those 2 points. This one goes through, this equation goes through 0, 0, so I can't pick 0, 0 as my test point. I can pick anything that's not on that line. So I'm going to pick this point right here. That's the point 0, 1. So I'm going to now test 0, 1. And when I sub it into my equation, again, I'm always going to go back to the original equation. That'd be 4 times 1 is less than or equal to 3 times 0. Is that true? That says 4 is less than or equal to 3. That is not true. That is not true. This point right here did not give me a solution to that inequality. And so I know I'm going to have to shade on the opposite side, right? That point did not work. We got to shade the other way. Graph the solution set. Here we have 2 lines. We have 2 separate lines. Let's graph them both. Remember, for an x is less than or equal to 1, remember for an x equals equation, that is going to be a vertical line at -1. And since it's less than or equal to, it's going to be a solid line. And I'm going to test this point 0, 0 to see if it works. Since it's not on the line, I can test 0, 0. That'd say 0 is less than or equal to -1. Is it? No, it is not equal to -1. It's not less than or equal to -1. 0 is not less than or equal to -1. That is not true. That means I'm going to have to shade on this side of that graph. On Alex, you'll just have a paint bucket, right? It'll be like a paint bucket with paint spilling out of it. You just tap the side that you want to shade. All right, on the next one, 3y greater than 5. If I want to get y by itself here, I'll pick a different color. 3y greater than 5. That's the same thing as y is greater than 5 over 3. That's any y equals line is a horizontal line. 5 over 3 is the same as 1 2/3 or 1.66. So that is going to be a dashed line straight through here, through 1.66. This is the line y is greater than 5 over 3. This one right here was the line x is less than or equal to 1. All right, we need to shade here. Again, I can pick 0, 0 as my test point. Test 0, 0. And let's see if 3 times 0 is greater than 5. Is it? Is 0 greater than 5? No, 0 is not greater than 5. That means we need to shade not towards that dot. We need to shade the opposite way, which means I'm going to shade up here. On Alex, sometimes it asks you just to graph one line, right, or one inequality. If I just wanted to graph A, that's my purple. If I just wanted to graph B, that's my pink. If it asked us to graph this as a system, let's say we had this as a system of inequalities, this is now a system, then I have to shade what's shaded for both, right? And the area that's going to get shaded here is going to be what's shaded both purple and pink. That's this region right here, the top right segment. This region. Oop, I went over that purple line, didn't I? Here, let's try this again. It's going to be this region. Everything that's shaded both in pink and purple. And so when you drop your paint bucket, you're not going to drop it on the top right or the bottom left, right? You're only going to drop it on the top left. We would end up, if this was a system, we would end up getting rid of, I didn't mean to do that, we would end up getting rid of all of the shading that was not in that top left portion. All right, this one looks a little bit different. You should be able to recognize this as a type of equation, right? This type of equation, this looks like a circle. And a circle has the equation x minus h squared plus y minus k squared equals r squared. Hopefully at this point in the semester you're recognizing things like this. And the center is 2, 0. And the radius is 3. And so when I go to graph it, the center's at 2, 0. The radius is 1, 2, 3. You can click any point that's 3 away. I'm going to try and get a good representative graph here, 3 and 3. And it's strictly greater than, you see that? And so now I'm going to draw a dashed line to make my circle. I'm not an artist, please don't judge me by my drawing skills. And I know this doesn't look like a circle, it looks like an oval, but I went 3 units in each direction, okay? When you graph on Alex, it's going to give you a little bit better circle here. All right, notice that 0, 0 is not on that equation, right? Notice that 0, 0 is not on the equation of that circle. So I can test 0, 0. I can test anything that's not on the circle, right? So I could test -2, 0. I could test 0, 3. I could test any of those points. I just like to test 0, 0 because it's easy. So if I test 0, 0, again, I'm going back to the original equation. That'd be 0 minus 2 squared plus 0 squared is greater than 9. I want to know if that's true. That would be 4 plus 0 is greater than 9. Is it? Is 4 greater than 9? No, it is not. 4 is not greater than 9. So I will not shade that way. That means I need to shade everything on the other side of that dashed line. And look at what my regions look like here. If I was to shade inside, I would stay inside the circle. Now that I'm shading outside, I'm going to shade everything outside of that circle, right? That's shading. It's not a lion's mane. It's shaded everywhere outside of that circle. All right, here we go. This is a system. We did see a system just a minute ago. Let's try and graph this one. We'll graph that line first. Here, I'm going to switch to black for my axes. Start at 2, and I'll graph this one in purple. So start at 2. Then to get my next point, I need to go up 1 over 2 since the slope is 1 over 2. Up 1 over 2. And that's going to be a solid line. And if I'm just going to get a general idea. If I test the point 0, 0, test 0, 0, I'll leave that for you to test, right? But I'm going to say that that is true. It does work, okay? I'm just getting a general idea right now. Remember, with systems, I'm going to have to shade one region that's a quadrant instead of like a half of the region. All right, with this one, I still need to get y by itself. So I could say subtract the 3x. So that'd be negative y is less than negative 3x plus 3. Divide by the -1. And remember what happens when you divide by a negative is that it flips that sign. So that's going to make y is greater than 3x minus 3. Okay, now I have something that I can graph. 3x minus 3. 1, 2, 3. Going to start at -3. And to get my next point, I go up 3 over 1. And it is going to be a dashed line because that's strictly less than. So this is the dashed line. Y is greater than 3x minus 3. This purple one was y is less than 1/2 x plus 2. All right, I still need to shade my pink one. Notice that 0, 0 is not a point on that pink one. So I'm going to test 0, 0. Again, I'll leave this for you to test, right? Test the point 0, 0 and see if it works. It does. So then I need to shade towards that pink region. Notice if I shade towards the pink dot that I have there, I get this shading. And I'm looking for only things that are shaded in both regions, both pink and purple. And look here, the piece that's shaded is this wedge. That wedge is shaded both pink and purple. That wedge right there. So when you go to graph this on Alex or on my lab, you only want to shade inside that yellow wedge that I just made. I can go back now and I can erase all of my pink shading. And I can erase all of my purple shading and just leave the one that had both. So we want points that work for both inequalities. This is a system of inequalities. Take a second and see what you can do with this one. I'm about to unlock my work in about 5 seconds. So if you graph them as blue and purple, they should look like that. When you test your points, the blue is going to be under that blue line. The purple is going to be under that blue line again, under the purple line. And so the area that's shaded for both is this wedge right here, right? You see that wedge right there has both colors. That wedge right there has both colors, so that's the wedge that we want shaded. And we can erase our shading off of the other regions. Erase the shading off that region, and erase the shading off that region. All right, last one. This is the last example of college algebra. We've got 3 inequalities that we want to graph. Let's start with the easiest ones, okay? So let's say we start with, I'll go pink for this one. Y is greater than -5. -5 is way down here. And y is greater than -5. Remember, a y equals a number is just a horizontal line. And since it's strictly greater than, not greater than or equal to, I'm going to have a dashed line. Y greater than -5. And if I test a point 0, 0, it will work. So I'll shade above that. Again, I'm just getting a general idea. I'm going to erase this pink shading later once I get my other graphs on here. All right, the next easiest, let's go with this. If I was to solve this for y, that'd be -y greater than or equal to -x minus 2, divided by the -1, and I would get y is less than or equal to x plus 2. So y is greater than or equal to, less than or equal to, I'm sorry, y is less than or equal to x plus 2. I'm going to start at the 2. I'm going to go up 1 over 1 to get my next point, and that is going to be a solid line. And I can test again the point 0, 0. And 0, 0 does work. And so anything now that's below this is getting shaded in purple. So now I have a wedge. You see this wedge. I'm going to highlight this wedge for you. This wedge right here. This is what we're looking at so far. We still have one more equation to graph. Let's pick another color for that equation. This one right here. If you're looking at that, that looks like a quadratic that starts at +4 and folds downwards. And so I need to go left one down 1 and right one down 1. You can look back at your transformations of graphing. Your graphing transformations lesson, I don't remember exactly what lesson that was. It might have been 2.4 or so. And I'm doing a solid line here because this was less than or equal to. And I'm going to test again the point 0, 0. When you test the point 0, 0, it does work. And so the red region, we're shading everything towards the dot, so everything down here. And now let's look for regions that are shaded both. Actually, it needs to be shaded in all 3. It needs to be shaded red and pink and purple. And so my region that's getting shaded is got to be in between all 3 of these. This region right here. That region right there is going to be shaded. Everything else we can unshade. That's the only region that's going to stay shaded. Wow, what a good looking graph. We did a great job there. I hope you guys are happy with what you've done here. And I appreciate you guys being on this college algebra journey with me.